Hello everyone, in today's video we'll be reviewing some calculus exercises. The first question here has to do with simplification and they are very straightforward and I'll just try to walk through the steps with you. So in A we have the expression x plus h cubed minus x cubed all over h. So what we do here is first to expand x plus h cubed, and we do this using Pascal's triangle, the coefficients in Pascal's triangle here, because we have an expression raised to the power of 3, we use the third row of Pascal's triangle to get the coefficient. So x plus h cubed would be x cubed plus 3x squared h plus 3x h squared plus h cubed. And then we have the second term minus x cubed, which I have appended here. And all of this is divided by h. So expand x plus h cubed, you could also do it traditionally by writing it as, so we could also say x plus h cubed is equal to x plus h, x plus h, x plus h. But you could easily get errors using this method if you're not very careful. So I would recommend using Pascal's triangle instead to get the coefficient. It's also faster that way. And now coming back here, we subtract x cubed from the first term on our left here, and then we are left with 3x squared h plus 3x h squared plus h cubed all over h. And now we factor out h in the numerator such that it cancels out the h in the denominator, and now we have 3x squared plus 3xh plus h squared. So like I said, it's very straightforward. I just want to walk through the steps with you so you can approach or attempt other exercises like this on your own. The sub question B is this expression. So we have e, which is the exponential to the power of x over 3x raised to the power of 2 over 3 minus x raised to the power 1 over 3 times e to the power of x again. And all of this is divided by e raised to the power of 2x. So the first thing we notice is that we have e raised to the power of x in both terms in the numerator. So we factor it out here. And we are left with these terms, 1 over 3x raised to the power of 2 over 3 minus x raised to the power of 1 over 3. All of this is still divided by e raised to the power of 2x. And we use the fact that e raised to the power of 2x is the same as e raised to the power of x times 2, which is e raised to the power of x all squared. So using this fact, we are left now with 1 minus 1 over 3x raised to the power of 2 over 3 minus x raised to the power 1 over 3. And we subtract these two terms and we get this here. 1 minus 3x raised to the power of 1 over 3 plus 2 over 3 divided by 3x raised to the power of 2 over 3. And then we still have our denominator, which is e raised to the power of x. So we have this now as our final expression. It doesn't get any simpler than this. And moving on to sub-question C, we have cos squared sine theta raised to the power of 4 plus sine squared theta times cos theta raised to the power of 4. We factor out cos squared theta, sine squared theta, and we are left with sine squared theta on the term on the left plus cos squared theta from the term on the right. And we use the identity sine squared theta plus cos squared theta is equal to 1. And so we have our final answer to be cos squared theta sine squared theta. Moving on to question 2. In question 2, we are asked to solve equations or to show that there's no solution. So showing that there's no solution here is, well, most equations have a solution. Either, if not in the real plane, then they will have a solution in the complex plane. So the reason why we have the option here to show that there's no solution is because this exercise is limited to, it assumes that the student has little or no knowledge about complex numbers. So they expect you to find real solutions. So it should be solve the following equations or show that there's no real solution. That would be better. But what I'll be doing is, even for the cases where we have no real solution, we are going to find complex solutions. So the first here is x cubed minus 2x squared minus x plus 2 is equal to 0. We factorize. So we factor out x squared from the first two terms and then just a minus 1 from the last two terms. So we have now x squared in bracket x minus 2 minus x minus 2 in bracket. And now we have x minus 2 common to both terms, and then we factor out x minus 2 again. So that leaves us with x minus 2 in bracket x squared minus 1. And all of this is equal to 0. We again factor out x squared minus 1 using the difference of squares. So x squared minus 1 can be written as x minus 1 x plus 1. So now we have x minus 2 times x minus 1 times x plus 1 is equal to 0. And if the product of any of two or more numbers is equal to 0, then at least one of them has to be 0. So our solutions to this equation are x equals 2, x equals 1, or x equals minus 1. And we move on to the next equation. Here we have the natural log of x squared plus 3x plus 5 is equal to 0. First, we take the exponential, we raise both sides to the power of e. And when we do that using logarithm rules, e to the power of natural log of x squared plus 3x plus 5 is just x squared plus 3x plus 5. And e raised to the power of 0 is just 1. So we are left with this now. And this we can solve using the quadratic formula, which I will write at the end of this video in case you don't know it. But it's something like, if you have an equation ax squared plus bx plus c equals 0, the quadratic formula says you can find the roots of this expression on the left by solving for x with this formula. So x is equal to minus b plus or minus square root of b squared minus 4ac all over 2a. So this is what I do. I simply plug in the coefficients we have in our question into the quadratic formula, and then we solve for x. So here we have x is minus 3 plus or minus. The plus or minus means we have two solutions. So it could be minus 3 plus the square root of minus 7 over 2, or minus 3 minus the square root of minus 7 over 2. Now, square root of minus 7 can be written as root minus 1 times root 7, since minus 7 is minus 1 times 7. And the root of minus 1 is a complex number I, imaginary number I. And so we have x equals minus 3 plus root 7i over 2, or x could also be minus 3 minus root 7i all over 2. And moving on to the third sub-question, and under question 2, we have sine squared theta minus 2 sine theta plus 1 equals 0. So this looks quadratic, so we try to simplify it. We try to represent sine theta as a single variable first, so that the expression is easier to understand and to solve, and the equation is easier to solve. So we let sine theta be equal to x, and then when we substitute that into our equation, we have x squared minus 2x plus 1 equals 0. And this we can factorize and then solve. So x minus 1 squared equals 0. That means x is equal to 1. And now we go back to the substitution we made. Remember, sine theta is equal to x. So we have sine theta is equal to 1. So theta is sine e inverse of 1. And that means theta can be pi over 2, which is the value in the first quadrant. But we know that sine has a period of 2 pi. So the sine of a number or any value plus multiples of 2 pi would still be the sine of the original value that we had. So theta can be pi over 2 plus multiples of 2 pi radians. And then sub question D, we have this equation e to the power of 7x plus 3 is equal to 2 to the power of 4x minus 9. Again, we take the natural logarithm of both sides, and then using logarithm rules, this can be written as 7x plus 3 natural log of e is equal to 4x minus 9 times the natural log of 2. And we collect like terms, so we bring the terms with x to the left and then the constant terms to the right hand side of the equation. And now we are left with this. Then we divide both sides by the coefficient of x, which is 7 minus 4 ln 2, so that we have x is equal to this. So this is the solution to our equation. And now question 3. We are given the absolute value function f of x equals absolute value of x. And we are asked to draw a graph of f of x first. So the graph of f of x is simply this, because we know that when x is positive or when x is non-negative, absolute value of x is just x. So 1 is mapped to 1, 2 is mapped to 2, minus 1 is mapped to 1, and 2 is again mapped to 2, and so on. So this is the graph of f of x. Then we are also asked to draw a graph of 3f of x plus 2 minus 1. To do that, we shift. So f of x plus 2, so here I denote, I use different colors to denote what I'm talking about in each point. So what we need to do to transform the graph is first, because we have f of x plus 2, we shift our original graph, the graph of f of x, to the left by 2 units. That's along the x-axis. Then because we have a 3, we scale the y-axis by 3 units. And then because we have a minus 1 here, we are going to shift downwards by 1 unit. So we're going to apply all of those 3 transformations. So the first step is shift to the left by 2 units. And that's what I do here. So we see here this yellow curve. Here. The curve this is pointing to is f of x plus 2. So I simply shift. My original curve is the blue curve, what we have here, this blue curve. I shift it to the left by 2 units, such that previously 0 was mapped to 2, now minus 2 will be mapped to, previously 0 was mapped to 0, now minus 2 will be mapped to 0. Previously minus 1 was mapped to 1, now minus 3 will be mapped to 1, and so on. So my yellow curve here is f of x plus 2. Then next is to scale the y-axis by 3 units. So I multiply all my y values by 3. So, and that's what I have in the green curve here. That's what the green curve here does. So we move from the yellow curve now to the green curve. So 2 now becomes 6. 2 times 3 is 6. And 1 now becomes 3. 0 times 3 is still 0. So 0 still stays at 0. 1 here becomes 3, and 2 here becomes 6. So we have the green curve to be the graph of 3f of x plus 2. And finally, we have minus 1, because we are to shift downwards by 1 unit. So we move our green curve down by 1 unit. So we had 6 here before. 6 minus 1 is 5. So 6 becomes 5. We had 3 here before. 3 minus 1 is 2. We had 0 here before. It shifts downward by 1 unit, and then we have minus 1. We had 3 here, shifts down to 2. 6 here moves down to 5. And we have our 3f of x plus 2 minus 1 curve. And then finally, we are also asked to graph minus 0.5 f of 2x plus 4. So the first thing is to scale the x-axis by half. Then we also scale the y-axis by half and then flip it because of the negative sign. And finally, we shift upwards by 4 units. So let's do that. So first, the yellow curve here is where we scale the x-axis by half. So this is what we have here. This yellow curve scales the x-axis by half. So previously we had 1 being mapped to 1, but now the 1 becomes half. So half is now mapped to 1. previously 2 was mapped to 2, but now 2 times half is 1, so 1 now becomes mapped to 2, and we do the same on the left hand side, and then we have now this yellow curve for f of 2x. Next, we scale the y-axis by 0.5 and flip, so we move from this yellow curve now to this red curve. So what we do is multiply the y values by 0.5, or we can say by minus 0.5. So previously we had half being mapped to 1. Half will now be mapped to 1 times minus 0.5, which is here. Previously 1 was mapped to 2. 1 will now be mapped to 2 times minus 0.5, which is minus 1 here. And we do that for all the other values, and then we obtain this wine colored curve here. After doing that, we move on to the next, to the last transformation, which is to shift our graph upwards by 4 units. So we are moving from this wine colored curve now to the green curve. And what do? We simply add 4 to all our y values. So previously we had minus 2 here. Minus 2 plus 4 becomes 2. Minus 1 plus 4 goes to 3. 0 here plus 4, 4. Not this one. Minus 1 plus 4 goes to 3. And minus 4 plus 4 goes to 2. So we have our green curve here. And then we join all the points and we get the graph of minus 0.5 f of 2x plus 4, which is what we want. And that's the end of this video. I'll just go over the key tools we used in these exercises. Number 1 is the binomial expansion with Pascal's triangle. This is very important, and this is just a brief introduction to it. But what Pascal's triangle does is to give you coefficients for when you are expanding expressions of the form a plus b raised to the power of n. So when you're expanding this kind of expression, you use the corresponding rules in Pascal's triangle. So for example, for a plus b raised to the power of 1, I simply take these coefficients 1 and 1, and I have a plus b. When I have a plus b squared, I take these coefficients 1, 2, and 1. So I have 1, 2, and 1. Then the powers of a reduce while the powers of b increase. And then I know I'm going to have 3 terms. So Pascal's triangle is very efficient and very helpful for binomial expansions. And you should try to go over it, especially if you are planning to take a calculus class, because it comes in very handy most of the time. Then I also use the difference of squares identity, and it's simply a squared minus b squared is equal to a minus b times a plus b. And it's good for you to take note that this is not the same as a minus b squared. It's a mistake that is easy to make, and I just wanted to point that out. They are only equal when either a or b is equal to 0. So take note of that. And then I also use the periodicity of sine. So sine and cos have periods of 2 pi, which means that sine of theta plus 2 pi still gives me sine of theta. So when you add 2 pi to any values and you find the sine of that value, it gives you the same answer. And finally, I use logarithm rules. So first, take note that when you see this symbol ln, it simply means the natural logarithm, and it's simply log to the base of e, the exponential. And then log a to the base of a is 1, because a raised to the power of 1 is a. A to the power of log b to the base of a is b. Log b raised to the power of n to the base of a is n log b base a. And finally, the log of a product is going to be the sum of the logs of the values in their product. So log bc to the base of a is log b to the base of a plus log c to the base of a. And here I simply rewrite the quadratic formula for you in case you need it. Thank you for watching. If you have any questions, please ask in the comment section. If you have any topics you would like to see more videos on, please indicate so in the comment section. And thank you for watching. Bye.